Architecture of 5G. Here, E2E management and orchestra here connected to business application layer. This is business enabled layer and infrastructure resources layer. Here, this is not coming in 5G under 5G architecture under use cases, business models, value proposition, operator services, enterprise, vertical, OTT, and third party. This is business enables APIs. This is virtualization. Sorry. This is only business enabled APIs. This is virtualization. Here, library of modular network functions and value enabling capabilities, CP functions, UP functions, RAT configure, state information, common information repository, virtualizations. These virtualizations, this is access node, this is cloud node, access node, networking node, external public private IP networks, 5G RAID family, RAT1, RAT2, RAT3, 5G devices, driverless car, robot, and etc. This architecture development of 5G data forwarding efficiency. For virtualized network focused on NFV technologies and the common equipment is the simplicity needed by service scenarios. For single machines, the price of basic hardware is smaller than price of specialized hardware detected technology. Through typically utilizes technology acceleration techniques that can increase forwarding performance in order to achieve the same data forwarding efficiency. More standard hardware than specialized hardware is required at the current technology stage. That often implies more space and more energy use. As a consequence, virtualization systems may be used first in the control plane. Fixed and mobile convergence after SDN. Since all fixed and mobile networks have implemented SDN technologies. Fixed and mobile networks have implemented SDN technologies. SDN fixed and mobile networks implemented SDN technologies. To know if the communication systems of the two networks are incompatible and what are the differences, how to obtain efficient control and optimal routing to be discussed in increasing potential user plane forwarding process and delivery scenario. How to obtain efficient control and optimal routing is to discussed in increasing potential user plane forwarding process and delivery scenario. Network capability exposure. This is not originally intended for 5G. However, in the 5G period, the exposure of the network capacity would be broader and greater, coupled with the centralization of the network control functions. For simple network connectivity, usable APIs and interfaces between the network visibility module and the required features needed to be further specified. 5G efficiency. The current 5G structure indicates that energy utilization can be decreased by 10 to 10% contrasted with the present 4G systems. 10% compared to 4G to be decrease. So it includes the reduction in the power requirements of wireless-based stations, antenna, and client devices such as smartphones, tablets, and Internet of Things (IoT) devices to broaden battery life. Nowadays, the key component for designing communication network is energy consumption. Based on this factor, the networks are being developed. On account of the transformation of technology, the data traffic in era, today's era is increasing every day. Due to this, the road trip time delay of the data packets rises higher in the network, which is turning into more noteworthy issues for the energy cost on 5G systems. The cell systems are the fundamental source increment in energy utilization telecommunications sector. The remedy energy consumption is the major challenge in meeting the green environment target and reduction in the cost of system. Heterogeneous network is a new trend which is increasing day by day in order to enhance coverage, capacity and power savings in the upcoming 5G network. The necessity for energy consumption, goal and operations will be significantly much more urgent with the advent of the fifth age of wireless systems with hundreds of thousands of progressive base stations and multi-millions of linked gadgets. It is expected before ended when compared with the today's circumstances. Traffic volumes are expected to be much higher than the current rate and the number of associated gadgets will be 10 to 100 times higher than today in the network. One of the enormous difficulties is to give thousand-fold increase in the capacity for billions of gadgets in a moderate and economical manner. Energy use of the network is a crucial consideration to reduce the total cost of ownership (TCO), including the environmental impact of networks. This capability is the core design concept. Here, energy 5G energy efficient, green and green 5G uh, development and planning, resource allocation, hardware solutions, energy harvesting transfer. Energy efficiency is defined as the number of bits that can be transmitted per joule of energy. When energy is measured across the whole network, the 5G network will accommodate a thousand-fold rise in traffic in the next 10 years. Although the energy usage of the whole infrastructure is just half of the existing system consumptions, this drives the need for an improvement in energy efficiency of multiply of 2000 in the next 10 years. Every practicable effort must be made to gain energy without debasing efficiency, but the technology should allow native flexibility for the operator to configure trade-off between the performance versus energy. There are different facts there which make the 5G network as an energy efficient network for the future. We have illustrated some parameters below. Sleep mode, high network data rate, dense small cell deployment, full duplex, massive multiple input, multiple output antennas, multimeter wave frequency band, sleep modes. The base station adjusts itself to sleep during in gap activities of network, thus reduces power consumption as the base station uses for even in high mobile networks doesn't surpass 20%, so the gadget's new base session enter into the sleep mode. Most of the base sessions remains idle for throughout the period of 24 hours and almost 80% of the power in any versatile mobile system is utilized by the base station in 24 hours. They can go into sleep mode repeatedly and remain for as long as possible. A technique to execute an advanced sleep mode is discussed in 37 reference cover. The idea of advanced sleep modes compares to continuous deactivation of base stations, parts of the diminished utilization of energy. Other proposed methodology to execute the advanced sleep modes and overseas clients whose administration demands happen while the base station drowsy mode. As the base station needs to wake up occasionally to send flagging blast to other. Okay, the system level simulation findings for hypothetical base station energy savings using time triggered sleep pattern. Millimeter power saving modes differing power consumption and deactivation. activation periods. In these methods, base station does not transmit and or receive something else that reacts to approaching DL user traffic by waking up. When the base station vacates, the procedure is switched to subsystems and segments in effect step by step activated. Numerous types of energy maintenance strategies based on the microcells level have been investigated in among various stages. The sleep mode is one of them. Sleep mode is the desirable type of small cell due to its low expenses in femtocells. It is lower power middle range state where it is switched off for only partial degree, presenting energy stage while not being recorded and activated repeated turn back to full service. This ensures improved effectiveness for either individual data rate or total collection capacity and power savings components of the femtool turn up separately from the ones required sensing user activity and the kernel network connection in order to on the femtool cell. Sniffer is used for detecting, it detects the rises receiver power on the uplink demonstrating the user microcells connection. Power saving among two modes divided as power savings equal to P micro plus P F, P M, FPGA plus P receiver plus P transmitter plus P amplifier minus P sniffer equal to 4.2 volts. Hardware component power consumption in watts. Microprocessor associated memory 1.7 volt. This asterisk mark parts that are switched off during sleep mode. So when switching sleep mode, switch off during sleep mode, 0.5 watts only consumption. FPGA associate memory 2 watts consumption, power consumption. While sleep mode, 0.5 watts consumption. Other circuitry 2 watts consumption, but here didn't mention while sleep mode how much power consumption in watts. So RF transmitter and receiver 1.5 volt power consumption in watts, 1.5 watts. RF power amplifier 2 watts consumption, power consumption. Here total clusters, that is a graph of deployment density versus the number of femtocells triggered to sleep mode. Here mentioning this is per user, this green per PS, this red per cluster. In x-axis total clusters formed. In y-axis femtocells turned to sleep mode. Higher network data rates. 5G services have larger data output and decreased packet latency. Higher data rate denotes that due to 5G networks, data transmission will be in shorter time. It would make the network link between the client and the base station ideal for longer period of time. These ideal times allow longer sleeping modes. Millimeter wave telecommunication is favorable technology for 5G wireless networks in the future. Because extremely high data speeds. Trends small cell deployment. Small cells are controlled by operators operating in licensed spectrum under collective term for lower power consumption and low cost based stations. High data rates can be provided by densely deploying them so as to significantly reduce the cell coverage to reach a high spatial spectrum efficiency. A large number of small cells must be deployed to achieve seamless coverage in urban areas and form 5G ultra dense cellular network. Small cells may be of different sizes of depending upon which they are classified as femtocells, picocells, microcells. Full duplex, where the fourth generation 4G mobile communication networks extensively uses orthogonal frequency division multiplexing (OFDM) as physical layer technology due to its higher band consumption strong anti-interference ability and strong padding ability. However,